Since 2014, Satya Nadella has directed Microsoft through its pivot toward cloud computing and artificial intelligence. Sundar Pichai has managed Alphabet and Google's search, cloud, and mobile ecosystems. Shantanu Narayan transitioned Adobe's entire suite of creative software into a subscription model, and Arvind Krishna has overseen IBM's transition into hybrid cloud infrastructure. These executives are part of a specific demographic cohort. As of July 2025, at least 11 Fortune 500 companies are led by CEOs of Indian origin. Collectively, these firms command over $6.5 trillion in global market capitalization. A concentration of corporate control at this scale requires looking past individual resumes. There is a sociological filter producing this specific type of executive. This scatterplot compares data from a study of 30,000 corporate executives. It shows that Indian origin leaders are statistically 5 times more likely to take calculated risks, and they score consistently higher on baseline resilience when measured against their peers. These traits trace back to the environment where these executives were raised. Daily life in India often requires navigating bureaucratic friction, infrastructure gaps, and high population density. It fosters a cultural mechanism known as jugaad, the capacity to improvise and solve complex problems within chaotic, unpredictable systems. That environmental conditioning is then paired with one of the most ruthless academic filtering mechanisms in the world, the Joint Entrance Examination, or GEE. This funnel illustrates the brutal mathematics of the GEE Advanced Test. Out of approximately 1.6 million initial applicants, only about 16,000 candidates secure a seat at an Indian Institute of Technology. That is an acceptance rate of less than 1%. Historically, this hyper-competitive environment functioned primarily as an export engine. The survivors of this academic gauntlet were frequently recruited directly into the American corporate ecosystem. This pipeline supplied the talent that eventually took over the highest levels of Silicon Valley. But the geopolitical and economic realities governing that talent flow are now reversing. This line chart tracks the financial trajectory of India's tech and IT services industry. By fiscal year 2024, the sector reached $254 billion in revenue. Running this economy requires enormous human capital, employing over 5.4 million people to maintain domestic infrastructure and global exports. Supported by this massive economic base, a distinct demographic shift is occurring. Elite technology veterans who spent decades building products in the United States are returning to India to launch locally headquartered, globally competing businesses. This boomerang effect supplies the exact executive expertise required to upgrade a massive IT outsourcing economy into an ecosystem capable of designing and owning its own products. Software capabilities are highly vulnerable without physical infrastructure. This infographic details the India Semiconductor Mission 2.0, a state-directed initiative moving capital away from pure software and into hard tech. Across 6 states, the government has approved 1.6 lakh crore rupees in total investments. The funding is actively being deployed to construct silicon fabs, packaging centers, and advanced testing facilities. Alongside physical manufacturing, there is a coordinated push to develop indigenous microarchitecture. The 7-nanometer Shakti processor, designed entirely at IIT Madras, proves the viability of an end-to-end Indian semiconductor intellectual property stack. Owning code is irrelevant if another nation cuts the physical chip supply. The semiconductor mission establishes the concrete foundation required for technological independence. That hardware base directly supports the next phase of the strategy, deploying raw computing power through the India AI mission. This map visualizes the deployment of 38,000 graphics processing units. These GPU clusters are offered at heavily subsidized rates, allowing local researchers to run complex AI training tasks. An additional 20,000 GPUs are actively being procured to expand this compute pool. By lowering the financial barrier to massive computing power, the state ensures that the datasets and foundational models governing the future of artificial intelligence can be constructed entirely within its borders. While the elite institutes continue to produce high-level leadership and deep tech breakthroughs, the strategy faces heavy friction at the base of the educational pyramid. This key findings infographic highlights a critical vulnerability. The overall employability of standard Indian engineering graduates recently dropped to 42.6%, driven largely by a deficit in practical application and non-technical skills. To correct this, technical colleges are currently pivoting their curriculums. The emphasis is shifting away from theoretical, rote memorization exams and toward project-based learning, coding practice, and direct industry certifications. Deploying capital for fabrication plants and AI clusters solves the hardware problem, but sustaining that infrastructure requires thousands of competent technicians, developers, and middle managers. Securing the lower-tier educational pipeline is mandatory. The convergence of these initiatives forms a singular objective: innovation sovereignty. It is the ability to maintain absolute control over the technology stack, from the silicon wafer up to the AI algorithm. The specific demographic resilience and problem-solving capabilities that previously built the leadership class of the American tech sector are now remaining localized. The raw human talent has always existed. Now, the physical infrastructure and domestic capital are finally scaling up to support it. With diaspora leaders returning, state funds flowing into hardware, and subsidized AI compute coming online, the question is whether India can successfully construct the next global epicenter of technology on its own soil.